So for this one, we're going to be covering a few things. One, we're going to do joules to calories, calories to joules, and then we're going to talk about like specific heat and all that, the equation of like Q equals S times M times delta T. Alright, so first off, we have calories. Calories, joules. In that instance, we multiply, how do we spell multiply? By 4.184 J. So the equation could look like, could be 60.1 cal times 4.184 J over 1 cal, and that would just equal 251 J. It's kind of like the molar highway of mass to moles and whatnot, but yeah. Alright, now for the joules part. Joules is the exact opposite. We divide by 4.184. So we have 28.4 J. We want to change that to calories. So what we're going to do, multiply it by 1 calorie over 4.184 J. Now, whatever you want to transfer to is going to be on the bottom because you got to cancel it out. The 4.184 always has a J next to it, no matter like where it is, top or bottom. And for that one, that would just be 6.979 calories. Alright, so now we're going to go over calculate changes in energy. And it's quite simple. The formula is Q equals M times S times delta T. Delta T equals change in temp. M equals mass. S equals specific heat. However, specific heat. Q equals energy required. So, problem might look like, or say something like, what is the quantity of energy in joules required to heat a piece of iron weighing 1.3 grams from 25 degrees Celsius to 46? So, energy needed in iron, blah, blah, blah. From 25 degrees Celsius to 46 degrees Celsius. Alright, so that might be one part of the problem. So what we want to do is view Q equals the mass of iron, so that would be 1.3 G, times the specific heat. So this, you have to look on your periodic table and you have to flip to the back. I'll pull it up real quick. Flip to the back, and it says it right there. Yeah, it says it right there. The camera focus. That's back to the problem. Then we do, since iron's specific heat is 0.44 J, it's 44 J over GOC, because you're going to have to cancel out the 1.3 grams and the Celsius. So it would be 21 OC, because that's the change from 25 to 46. And then once you just multiply across the board, you will get 12.0 J. Now it might ask you to convert to calories, and then you just multiply that by divide it by 4.184. Alright, so another question could look like this. How much heat is released when 1 gram of iron is reacted with excess O2? And this is when delta H gets first introduced. You want to balance the equation first. Then, from there, you take 1 gram Fe and change it to moles. then you multiply it by delta H, and that would just be negative 1652 over however moles of iron you're reacting with, you start out with. So in this case, it'll be 4. And then that will get you negative 7.40 kJ. Now, it might ask you to put in calories. Again, you just got to divide it, but that's what it'll look like. For people with calculators, do not divide negative 1,652 by 4. Multiply by negative 1652, then divide everything by 4. And then just real quick, I don't think I'll ask this, but if you need equations to go to and from different degrees, you just gotta do all of this. So you have Kelvin to Celsius, Celsius to Kelvin, Fahrenheit to Celsius, Fahrenheit to Celsius to Fahrenheit, and you can't go from Kelvin to Fahrenheit, Fahrenheit to Kelvin. You have to pass through Celsius. And then up here is just like the chart he had us do, like what each thing is. Yeah, that's pretty much that. He started to mention this. It was just kind of weird. I don't think he'll actually do it, but for this case, he was trying to explain to us that converting it to like Fahrenheit to Celsius, you can't just like straight up do it. You can't follow this equation. You have to follow the actual delta T equation for like changes. Okay, not normal stuff. So if he just straight up asks you like put 32 Fahrenheit into Celsius, you do the equation for that. For this though, for delta T, you have to go from Fahrenheit to Celsius, you have to multiply by 1 Celsius over 1.8 Fahrenheit. And over here on the chart, he kind of like explained it by the numbers of 212 is water boiling and freezing, and it's 180 difference. That's 100 difference, so it's just 1.8. And you kind of see that down there to go from Fahrenheit to Celsius, Celsius to Fahrenheit. That's only if he's asking you to convert delta T into Celsius. Okay? Just know that. So what you gotta do for this, just convert this into Celsius, and then just convert that also into Celsius, and then you can do it from there, and just do normal delta T from there.